Hello everyone, welcome to Career Launcher. So we are now today going to look at geometry of solids, eighth geometry session we are meeting for. So we have discussed all the 2D geometry based concepts. Right, so today we'll look at solid geometry, geometry of figures in three dimensions, right? What are the different solids? Well, we know like cube, cuboid, basics, then right circular cone, right circular cylinder, sphere, right? And on the broader level, also, questions have been asked on the broader theme of prism and pyramid, right? So we'll look at all that, right? So, in these questions, I mean, first of all, we need to know all the different formulas, right, for the surface areas and the volumes of the different solids. Uh, but beyond than just the basic questions are which are formula driven, there are some very intelligent questions asked where some kind of visualization skills are required, because ultimately you see we are solving problem related to three dimension, right, a solid object. So when we are solving, then we are only able to draw the figures on a plain paper or 2D. So understanding the 3D visualization of the problem and problems related to that, where you have to visualize the figure like that, and that can be a bit of a challenge sometimes, and questions are asked in very different styles. So we'll look at all the different things. Let's see, right? Okay, so people, let's start with this session. As always, we look at first some previous year questions and then some more, right? Let's see. First one, CAT 2020 question. Let's see. Okay, so there's a right circular cone, something like that, of height 27 centimeters, is cut into two pieces along a plane parallel to its base at a height of 18 from the base. So 18 centimeters would be two-thirds of the height. So something like that, it is cut, right? So that this height is 9 and the total height is 27. If the difference in the volume of the two pieces is 225 centimeter cube cc, the volume of the original cone is. So this is a very basic question where you have to understand that volume of a cone is 1 by 3 pi r square h, right? Now, in this case, when the height will, I mean, for the smaller cone, when the height will change, the radius will also change, obviously. So the point is that the radius and height are in the same proportion in the two cones, the smaller one and the larger one. So the point is that effectively the volume is proportional to, because radius is proportional to height itself. So it is height square into height, height cube. Right. So just like in 2D figures, the areas of two similar triangles are in the ratio of the square of their corresponding sides, right? So वहाँ क्योंकि हम 2D dimensions में वर्क करते हैं, तो एरिया है जो कि साइड स्क्वायर है, मतलब एरिया इज डायमेंशन स्क्वायर, राइट? So area is proportional to square of the side length. Here, volume is proportional to the cube of any one edge length, as long as the edges are in the same proportion. So obviously for the smaller cone that will get formed and the larger one, the radius and height are in the same proportion, right? Okay, so therefore, since this height is one-third of the total height, 27, so the volume of this smaller cone has to be cube of 1 by 3 factor, or 1 by 27th of the volume of the original cone. So I can say that the volume of the original cone is 27 times of this smaller cone. So if the total volume we take of the original cone as, let's say, 27x, then the volume of this cone is x, right? And that means the volume of this solid left below is 26x because 27x is the total. So he's talking of the difference on in these two volumes. So 26x minus x, which is 25x, is given to us as 225. 25 into 9 is 225, so x comes to be 9. So the volume of the original cone, which is 27x, is 27 times 9, that is 243. Next, just a question related to the concept of the fact that if two solid objects, are similar in the sense that all their dimensions are in the same ratio, so their volumes are in the ratio of the cube of the ratio of their corresponding edge lengths, right? So I hope you can understand this, this uh, analogy between 2D and 3D geometry, right? So that was this question all about. Okay, let's see next one, people. Now, here we go. Category 17. The base of a vertical pillar with uniform cross section is a trapezium whose parallel sides are of length 10 and 20 centimeters, while the other two sides are of equal length. The perpendicular distance between the parallel sides of the trapezium is 12. If the height of the pillar is 20, you have to find the total area of all the 6 surfaces. What is this pillar like? Uniform cross section. The first sentence. Any object with a uniform cross section is basically a prism. A prism is a general type of all those solids in which there is a constant cross section. For example, a right circular cylinder is a prism with a circular base. I mean, it's not wrong to say like that. Here we have a trapezoidal prism. Okay, so draw the base. It's a isosceles trapezium. Other two sides are of equal length. The parallel sides are 10 and 20. Yeah, something like that. Let's try one more time because it's a symmetrical figure, right? Yeah. Okay, we'll do with that. Now, so this is 10, this is 20. First of all, you need to solve the geometry of the base prism, base trapezium. Now, it is given that also that the perpendicular distance between the parallel sides is 12. So this height would be 12, right? Also drop the other height also. This is an isosceles trapezium, that is 10. So this much is 10 as well, right? And the other two parts left on the base will be equal because they are congruent triangles, right? So the remaining 10 is going to be split equally. So this is 5, this is also 5. That means this is a simple 5, 12, 13 triplet. So the non-parallel sides are of length 13, right? So that gives us the geometry of the base. Now, as far as the solid itself is concerned, it's a trapezoidal prism. So it so on the top also you'll see the similar kind of top surface, and that's how the solid would it would look something like that. Yeah. So I hope you can get the picture of the solid now. It's a trapezoidal prism, right? You need to find its total surface area. So first of all, take the areas of the bases and the top. So what is the area of each trapezium? We have to have two such surfaces. Trapezium is half sum of parallel sides into the distance between them, half into 10 plus 20 into the height of the trapezium, right? Not the height of the pillar, right? Which is 12. Right, 15 into 12, 180, right? 30 by 2, 15 into 12, 180 square centimeters is the area of one trapezium. So we'll have two such trapeziums. Apart from that, we'll have these rectangular surfaces along the the whole solid. So those rectangles will have one of the edges as the base length, one of the base edge length of the trapezium, and the other will always be the height, which is the constant 20 centimeters height, right? This height is 20, common to all. So now we can finalize the total area of the trapezoidal prism. So twice the area of each trapezium, the base and the top identical surfaces, plus, can you understand, each, there are four surfaces, right? Rectangular. Edge length into height is common. Edge length plus edge length plus edge length is basically the whole perimeter. So whole perimeter of the base trapezium, which is 10 plus 13 plus 20 plus 13, right? This 10, this 13, this 20, this again 13, into the vertical height of the pillar, which is 20. So that should be the total area. So this is 360, this is 10, 20, 30, 43, 56. 56 times 20 is 360, and 56 2s are 112. So 1120, that is coming to be 1480 square centimeters, right? So I hope that this trapezium idea is clear. Trapezium are all those solids which have constant cross-section area, right? In general, the total area of all such trapezium will always be what? Twice the area of the base, plus the base, plus the base of the perimeter into the vertical height of the solid. Yeah. Okay. Now, right, let's see, people. Next one. Pyramid. The base of a regular pyramid is a square. So what is a pyramid? Well, all of us know pyramids of Egypt, right? So I mean, all of us have seen them. So geometrically, what they are. So see, I mean, the pyramids of Egypt, they are all square base pyramids, right? So in general, pyramid concept is beyond just what we see, there. It is basically all those solids which have a base, which could be any shape, right? It could be any polygon, and then the it tapers to the top to a apex, a point at the top, right? It's tapering upwards, right? Okay, so let me draw this figure for you. The base of a regular pyramid is a square, and each of the four sides is an equilateral triangle, length of each side being 20. So something like this. It's a base is a square, right? Remember, this 20 is not the side length of the base square. It is the side of the equilateral triangle. Now, what are those equilateral triangles? So as I was saying, this solid will taper towards the top to a point, right? Means there is a common point to which each of the edges have to be joined, basically. So, something like going there, yeah. So I hope this you can visualize. Yeah. Now, so there are these now in the previous question of prism, there was these rectangular surfaces along the solid, but now these are triangular surfaces along the solid because of the tapering effect, right? So these triangles he's saying are of edge length 20. By the way, it does so happen that since these triangles share this base with the square base also, so the square base also becomes of side length 20 effectively, right? So this 20, this 20, and this base 20. Now we have to find the vertical height of the pyramid. Okay, so let me draw this because this is an imaginary line now that I'm drawing, right? This vertical height is this vertical drop from the apex to the base of the pyramid, which will be falling exactly at the center of the square because of the symmetry. So to find this vertical height, now what do we do? Well, we know these are triangles of side length 20. So consider this edge, this is 20 length edge, right? Now join this center of the base to this vertex over here. So this will be right triangle simply because this is a vertical line and this is the line along the base, right? Now what about this length? Because we want to find this height h. If we can find this length, I think we are through because we already know this is 20, right? So yeah, so obviously this much is nothing but half of the diagonal of the square. Diagonal will be 20 root 2, right? Because this is also 20, because this is an equilateral triangle given to us, right? So therefore this is half of 20 root 2, 10 root 2. So 10 root 2 and 20 means 10 root 2, right? So 1 is to 1 is to root 2. It's a, this triangle is a right angled isosceles triangle. 10 root 2, 10 root 2, 20 right angle triangle, right? So, right, this is the concept of pyramid, right? So, visualizing this solid, I hope that was clear, that in general, it could be anything. It could be a triangular pyramid, it could be a hexagonal pyramid, the base could be any polygon. Basically, you need to join the vertices of the base polygon to a point on the, a point called as apex, where the solid is converging towards, right? ओके राइट. सो देखिए, रिसेंटली एक क्वेश्चन है, कभी भी दोबारा रिपीट हो सकती हैं चीजें, राइट? प्रिज्म पिरामिड क्लियर होना चाहिए, राइट? चलिए और देखते हैं. नाउ so a very good question, requiring a lot of multiple concepts over here. Let's see. Consider a right circular cone of base radius 4 centimeters and height 10. Cone is well defined. A cylinder is to be placed inside the cone with one of the flat surfaces resting on the base of the cone. Draw the figure first of all to understand what's happening. There's a right circular cone, right? So there is a inscribed cylinder. I mean, it's not a 2D shape, but basically the idea is the largest possible. A cylinder is placed with one of the flat surfaces resting. Find the largest possible total surface area. So obviously, if I have to maximize the total surface area of the cylinder, I would like, it will be touching the cone from inside, so that it is the largest possible solid itself. But then again, those so many different such cylinders can be placed, right? In the sense that where what is the exact height and radius, all that can vary. So we have to take that optimum cylinder for which the area, this total surface area is maximum. So the cylinder would be something like, touching the cone from inside. But where I'm placing this is exactly, it can vary, right? So there'll be different such solids, there'll be different such cylinders. So we have to consider the one which will maximize the total surface area. Obviously, that's a question that is left best to algebra, right? In the sense, we need to define the total surface area in terms of its parameters and then maximize that. Now, consider that the cone itself has radius 4. So this total radius over here is given as 4, right? Whereas the total height is 10. Let's say the height of the cylinder is h, okay, and its radius is r. So this is r and this height is h. Since the total height is 10 for the cone, so this distance is going to be 10 minus h. What I'm trying to do is I'm trying to find some relation between the radius r and the height h of the cylinder. Can I say this theta, if this theta is there, then tan theta for the smaller triangle over here equals r over h, r over 10 minus h, my bad, right? R over this triangle, right? R over 10 minus h. But at the same time, for the larger triangle, so the same tan theta is basically the bigger radius 4 upon the total height of 10, which is 2 by 5. So the point is, these are similar triangles. I mean, these two. So from that similarity of triangles, basically I'm looking at the front cross-sectional area of the solid. right? And I'm applying 2D geometry with respect to that similar triangles, right? So here is the relation between the radius and r and height that I was trying to find. So can we say that r is 2 by 5 into 10 minus h, right? This goes there. Or you can expand this also. 2/5 of 10 is 4 minus 2 by 5h. Right, so now we need to define the total surface area of the cylinder in terms of its parameters, which is, we know 2 pi r h plus 2 pi r square, right? Total surface area. The curved surface area 2 pi r h plus 2 pi r square. The top and the bottom both pi r square. So this is 2 pi r h plus 2 pi r square, or you can say 2 pi r h plus r, right? Now let's substitute for r over here that we have obtained from above and define the area in terms of as a function of h, right? Then we have to kind of maximize that. Looks like we should get something in quadratic because this is, obviously second degree expression. So 2 pi into r, which is 2 by 5 10 minus h into h plus r. So h plus 4 by 4 minus 2 by 5h, which will be 4 plus 3 by 5h, right? Minus 2 by 5 plus 1h is plus 3 by 5h. So this is what you have to maximize. So the total surface area as a function of the height h is therefore this expression. This is 4 pi by 5 here. Also, I see I need to take one factor of 5 from the denominator in this second term. So I'm taking 4 pi by 25 here. Then I have this as 10 minus h. And this is 4 5 is 20 plus 3h. Now let's just focus on this quadratic expression which you have to maximize, and then our job is done. Right, so बस अब हम इसको देख लेते हैं, इसको expand कर लेते हैं, right? So let's just expand this. I'm just expanding this over here. So this is 200, this much, 200 and plus 30h minus 28, so plus 10h minus 3h square. So we have to maximize this. So this is minus 3, take common, h square minus 10 by 3h minus 200 over 3. I've taken minus 3 common to make a perfect square. So yeah, so this is minus 3 now. So h square minus 10 by 3h. So for the completion of square, h minus 5 by 3 whole square will give me h square minus 10 by 3h plus 25 by 9. So I have to subtract that. So this is minus 200 by 3 minus 25 by 9. Okay, so finally, what is this? Minus 3 into this. This is 200 by 3 plus 25 by 9. That will be 600 by 9 plus 25 by 9. 625 by 9 into minus 3. So 625 by 3. Yeah. Perfect. This is minus 625 by 9 into minus 3. Minus minus cancels. 625 by 3. And minus 3 times of h minus 5 by 3 whole square. So obviously, this expression, the maximum is 625 by 3 by choosing h, the height, to be equal to 5 by 3, which is quite possible, right? So therefore, at height equal to 5 by 3, this is the maximum value. So the maximum value of this, right, this whole expression, its maximum is coming to be 4 pi by 25 times of 625 by 3. Perfect. Yeah, so 25 cancels. This is 25 square, 25 to 400 pi by 3, the very first option. Okay, so as I said, it was a maximization question, so obviously some algebra has to be involved, but before that, geometry was the prime thing in order to find this relation, over here between the radius and the height of the cylinder. Right, shall we? Perfect. देखते हैं what else we have. Next one. A very brilliant question, this one, which came in CAT 2017. CAT 2017 was one of those exams, which came with lot of intriguing questions. One of the most difficult levels of quant. Right. So this, as I said, here a lot of visualization skills will be required. A ball of diameter 4 centimeters is kept on top of a hollow cylinder standing vertically. Oh my God. You see, you have to visualize this figure carefully. Now, if the ball is smaller than the cylinder, it would have just fallen through the cylinder, but it is kept on top. Means definitely this ball has its diameter greater than the diameter of the cylinder, right? For sure. Now we can verify that from the data. So this ball is of diameter 4. The height of the cylinder is 3 while its volume is 9. So we can find the radius of the cylinder to begin with, right? So pi r square h is the volume of a cylinder, and that is given as 9 pi. And h, the height, is also given as 3. So pi r square h is 3, and that is equal to 9 pi. Pi cancels, 3 cancels. So r square is basically coming as 3. The radius, therefore, of the cylinder, the hollow cylinder, is root 3 centimeters. The radius of the diameter, the radius of the ball is 2. 2 is more than root 3, so yes, makes sense. We have to find the vertical distance of the topmost point of the ball from the base of the cylinder. Now let's draw the figure over here. Can I just erase this, or let me just put it over here? Right, pi r square h was basically 9 pi, h is 3 pi. So 3 pi r square was 9 pi, r square is 3, r is root 3. Right. Okay, so yeah, so now there is this hollow cylinder of height 3. Now, the ball is something like that. It will be resting, something like this on the cylinder, right? So I hope you get the point that its diameter being greater than that of the cylinder, it will be, its part will be inside, obviously, some part. Now, so we will solve the geometry of this figure. Again, we're looking at the cross-sectional, front cross-sectional area, and we're solving the geometry. For me, this is a rectangle, that is a circle, right? I mean, I'm solving it by looking at its front cross-section. So now, what is happening? The radius of the ball is 2. So at this point, I'll join from the center of the sphere, and this is 2 centimeters, the radius of the ball. This being the radius of the cylinder, root 3, right? So therefore, this is obviously right angle triangle over here. So this is root 3, this is 2, this is simply 1, right? I think the problem is pretty much done, right? So you're looking for the distance between this topmost point of the ball and this base of the cylinder. The other two things that are left, you easily know. This इसको ही निकालना हमारा सबसे बड़ा टास्क था कि ये जो हमने ये पार्ट निकाला है. So right, so basically there is another length 1 going below, because the radius is 2. Right, don't go by my sketch. So basically you can say I mean, the whole diameter is 4, so 1/4 of the portion of the ball, not volume wise but height wise, because 1 centimeter is inside the cylinder, right? So therefore our answer is, this is 2 and this is the height of 3, so 3 plus 1 plus 2, 3, right? So 6 centimeters is the required distance. All right. तो अपने देख रहे हैं कि मतलब हमारा यहाँ पर मतलब सॉलिड ज्योमेट्री है, तो हमें फिगर की विजुअलाइजेशन जो है वो बहुत इंपॉर्टेंट होती है, राइट? चलिए, तो हमने प्रीवियस देख लिया, अब थोड़ा सा एक्स्ट्रा क्वेश्चंस देखते हैं. लेट्स सी और क्या है देखने के लिए. नेक्स्ट क्वेश्चन नाउ. Okay, something again on cone and sphere. Let's see. A conical tent of radius 12 centimeter and height 16 centimeter contains the largest possible spherical ball. अभी पिछले क्वेश्चन में बॉल वाज रेस्टिंग ऑन द सिलेंडर, बट इन दिस केस इट इज completely inside it. A conical tent contains the largest spherical ball, means it is inside the tent. What percentage of tent's volume is occupied by the ball? Obviously, you would inscribe the sphere, in the sense you would want the sphere to be touching the walls of the tent from the inside, right? आप तो उसके अंदर घुस नहीं सकते, right? Means there's no space for anything else to enter. I mean, the ball is as large as it can be, right? So once again, it's about the front cross section that I'm looking at, and for me the geometry is that this is a triangle for me, although this is a cone, but for me I'm looking at this front cross section, and a sphere is inscribed in the cone, or for me it is like a circle is inscribed in a isosceles triangle. Like, so I hope you understand the analogy, right? um, right, so I'm trying to find the radius of this sphere. Now coming to the geometry part, as I said, I'm looking at the front cross sectional area. The radius is 12, the height is 16, the total height is 16. Now solve the geometry. Let's say this is radius r. Always remember, you always get these similar triangles, in this. Now I'm solving a triangle and a circle geometry. Always you get these similar triangles because this theta is common, and this is 90, this is 90. So this small triangle over here and this larger triangle, this triangle is similar triangles. So you can write that the ratio of corresponding sides is equal, and you should be able to find the radius r. The whole height is 16, remember, right? The whole height is 16. Okay, so opposite to theta in the smaller triangle I have r, and opposite to the larger triangle, opposite to theta, I have 12. Now what else do I know? Well, opposite to 90 in the small triangle, what do I have? Since this is r, the whole height was 16. So 16 minus r is opposite to 90 degree, this much, right? This being r. And opposite to 90 degree in the larger triangle is 12, 16, 20, right? This 12, this 16, so the slant height is 20 of the cone. Perfect. So that is the equation based on similarity of these two triangles. I can clearly see I should be able to find the radius, and hence the answer, right? So this is 4 cancels. I'm getting 5r. This is 5 equals 16 3s are 48 minus 3r. 8r is 48. R is coming to be 6. Perfect. So all that is left to do is take the ratio of the volumes. So the sphere, the volume is simply 4 by 3 pi r cube, 6 into 6 into 6, right? So this will cancel. 36 into 2, 72 into 4, 288 pi cubic centimeter, right? 36 into 2, 72, 72, 144, 288, right? And as far as the cone is concerned, so it's 1 by 3 pi r square h. R, the radius is 12, so 12 square into the height is 16, right? So again, what do I have? Well, 16 into 12 into 4, 48. So I'm just writing it like this, pi, right? So take the ratio. The ratio of the volumes is this by this by this. 288 pi upon this. This is, so yeah, so this was 36 into 8 basically, or you can say 18 into 16 also. So 16 will completely cancel. 16 ones are 16, 128, 18. Pi cancels. 18 by 48, 6 cancels, 3 by 8, right? 3/8 is the ratio, or 37.5%, right? तो क्वेश्चंस आपके इस तरह के जो होते हैं जिसमें कि a solid object and another one is kept inside, ultimately it's a 3D figure, but to solve the geometry you have to consider the front cross sectional area and solve the 2D geometry involving the that the way the cross sectional looks like, right? Okay, so this was this. Now let's see next one. Now look at this question, very interesting. The circumference of a cylinder is 3 feet and its height is 16. Circumference, not the radius, circumference. So we have a cylinder. Its dimensions are perfectly given. Now question is not calculation driven but more logical. An ant climbs the pole in a spiral such that one spiral helps it to cover 4 feet in height. Now, so imagining this is the only challenge. The ant starts from here and its motion is a spiral. So, I can only show you a screen in front of you, but you can imagine it's revolving around and moving in a spiral. So something like this, it keeps on going like this, and four such spirals helps it to reach the top, right? Now, because why four? Because it covers 4 feet in height with one spiral. So one such spiral is 4 feet, and so the total height is 16. So four such spirals will help it to reach the top. Thus, when the ant reaches the top, what is the total distance covered by it? Very interesting. Now, so you have to consider, basically one such spiral and what is the distance covered by it. So, what you have to imagine is just think about this is one spiral covered. Just think about cutting the cylinder from that point where one spiral has been covered, right? So think about this portion of the cylinder is 1/4 of the cylinder. Consider opening the cylinder in the sense, imagine as if it's a hollow cylinder, right? I don't care whether it's a solid or hollow cylinder, right? So imagine it was just a sheet of paper that was rolled around, and imagine opening it around. What would you see? How would the path of the ant look like on that opened rectangular sheet? So imagine this was the circumference of the base, 3 feet. This is the height of 4. And I hope you can imagine this, that the path of the ant would basically be the diagonal of this opened rectangle. इमेजिन ना कि आपने इसको एंड टू एंड ज्वाइन किया हुआ है, तो ये पॉइंट इसी के साथ तो मीट करेगा ना, तो अल्टीमेटली द एंड वुड हैव डन द फुल रेवोल्यूशन around the circumference, and that path when opened looks like the diagonal of this rectangle, which is simply the 3 4 5 triplet, isn't it? So 5 centimeters has been covered by the ant in one such spirals. The ant has covered 4 such spirals. So therefore, 20 feet, 5 into 4 is the total distance covered by the ant. Right? So I hope that you understand now my point कि कैसे हमें ऐसे क्वेश्चंस आ सकते हैं जिसमें कुछ हमें विजुलाइज करना पड़े. अब you're opening a hollow cylinder, you're imagining the path, जो देखने में तो एक एलिप्टिकल पाथ लग रहा है, स्पाइरल टाइप, बट उस कर्व सरफेस को ओपन करेंगे तो इट्स अ स्ट्रेट लाइन पाथ व्हिच इज द डायगोनल ऑफ दिस रेक्टेंगल, राइट? So I hope this was fun, interesting, and you caught the point that अगर ऐसा कुछ क्वेश्चन आता है स्पाइरल तो you know what to do. ठीक है, चलिए और देखते हैं. लेट्स सी नेक्स्ट वन. अरे भाई फिर से एंट आ गई. देखते हैं, कुछ इंटरेस्टिंग है फिर से. लेट्स सी. An ant is sitting at a top corner of a cubicle room of side 25 feet. right? That's your cube. An ant is, let's say, here, point A, ant, right? It needs to reach the farthest corner on the floor without leaving the surfaces of the cube. This point, let's say B, and has to go from A to B without leaving the surfaces of the cube. To the nearest integer, the least possible distance the ant needs to cover in feet is. Now, if this was not an ant but a fly, you would have done the the body diagonal. You just flown directly from A to B. You can't do that. You are an ant, not a fly. आप उड़ नहीं सकते, आप सिर्फ चल सकते हैं surfaces पर. क्या करेंगे? So mostly what people do is, वो क्या करते हैं? I'm just saying. Mostly what I see people doing is कि वो ये edge length cover कर लेते हैं, यहाँ bottom तक पहुंच जाते हैं और फिर यहाँ पर ये surface diagonal cover कर लेते हैं. That I see mostly as a response from students on this question. I think if you, I think most of you would have thought like this even now, but this question is not so simple. There's a much better optimization. So what is happening? मैं आपके आंसर को पहले बता देता हूं. आपने कहा a is 25 feet, the side length of the cube. Mostly people answer as a plus root 2a. Most common answer is a plus root 2a, which is not the correct answer. I'm just comparing your answer, the most common answer, the most common wrong answer with the actual answer. Right? ये आपने edge length cover किया, like कोई भी आपने ऐसे कवर कर लिया और फिर यहाँ से आप ऐसे चले गए. मैं ड्रॉ नहीं कर रहा हूँ, but I hope you can understand. I'll give you the much better approach. See, this ant is not so dumb. What is it going to do? See, it is looking at this solid and it is like in its mind, it is opening all the flaps of the solid. Again, imagine this not as a solid. Imagine this being a room and these being like flaps of a hollow cube. So imagine this flap, over there, and this flap on the right side, right? The back flap and the right flap. Imagine opening them. Imagine this back side and this right flap, this right side. The ant is here, it has to go here. As soon as I draw this rectangle, I hope you have got the point. It's not about following the edges of the cube. It is about following this shortest path. Eventually, it is these two squares, which when opened, the ant would get the idea, go along the diagonal. Right? It can only walk. Right? This is A, this is A, this is A. This is 2A and A, right angle triangle. So 2A and A, this AB distance in this case is root 5A. Root 5 is less than root 2 plus 1. देख लीजिए, root 2 is 1.414. Plus 1 is 2.414. Root 5 is 2.236. That is 2.414. Improvement है. So that is the answer, people. Root 5 edge length. That is the shortest path. इसको आप देख लीजिए कि what does it come to for this 25 root 5. 25 into root 5 is approximately 2.236. So I will do it like this, 100 by 4. Easy to do. 223.6 by 4 is approximately 4 5 is 20, then almost 24. 4 6 is 24. 56 feet. Right, people? So I hope this was fun as well. Right, so solid geometry is not just about knowing the formulas of volumes and surface areas. It's not just like that. देखिए आपके क्वेश्चन जो आए हैं प्रिज्म के, पिरामिड के, उसमें पूरा विजुअलाइजेशन चाहिए होता है. सिर्फ फॉर्मूले से काम नहीं चलता है. फिगर बनानी पड़ती है, फिगर बनाए बिना बात समझ में नहीं आती है, राइट? सो देयरफॉर दैट इज माय मैसेज, जस्ट डोंट रिलाई ऑन अच्छा मुझे फॉर्मूलेज आते हैं सबका, मेरे को तो आता है, नो, राइट? Okay, so that was today's meeting, and we'll meet once again. Right, ज्योमेट्री में अभी भी एक सेशन हमारा अभी भी बाकी है, कोऑर्डिनेट ज्योमेट्री, right? That will be our next one. Till then, thank you so much. Thank you, people. I'll see you again. All the best.